In this lecture, we are going to learn how to use SQL in a big data environment using Cloud Data Impala interface. This is an essential skill that many business analysts have to have these days. Big data is not just for data scientists who specialize in the underlying architecture, extracting large amounts of data from typically data warehouses so that it can be used for multiple purposes. But the business analysts are increasingly using big data without going to the data scientist, and they have to have the skills to extract the data. And they might be interested in conducting small visualization to better understand their day-to-day tasks or share certain recommendations, business recommendations with their managers. And they might be interested in not just retrieving data, but also interested in doing predictive modeling, understand the statistical relationship within the data, and so forth. So a modern business analyst in a big data environment has to have multiple skills. And this lecture is going to focus on the use of big data using Impala SQL interface. I'm not going to go over how to install Impala SQL. You should be able to find, but this particular environment that I'm using, I was going to say you can find the instructions to install Cloud Data VM. Typically, if you want to give it a try instead of using your organization's big data interface, you can teach it yourself using typically a virtual machine. Here, in this case, I'm using a Docker interface and using a Cloud Data in a Docker container. Cloud Data Quick Start is what I'm using. And this is installed in my case in Apple Mojave operating system, which is the latest system available as of November 2018. And I have basically installed the tutorial example, and there are again instructions how to install the tutorial examples to practice in Cloud Data documentation that you can Google search and find. In addition to those tables, I also have constructed two tables. I will explain them first. As far as our operating system is concerned, I'm using, as I said, Mac OS Mojave version 10.14. And when you first install Cloud Data, you will see this screen. And in the first exercise, there is an instruction on how to install the sample database here. This is what I have done, and you have to open up the terminal. After installation of Cloud Data Quick Start, you will basically run this set of commands. It's a scoop command. It's a scoop job that copies a bunch of tables, and once you do that, you have access to all these tables. And this is your interface screen, and from the navigation here, you can launch the Hue UI user interface, and that's what I have done, and that's the screen. And I'm going to maximize it now. This is how the screen looks, and if you are using an earlier version, the screen obviously will look different. And if you say, you can type in your commands, or before I do that, I must explain to you the different components of the screen. And this is the Hue user interface, and this is our default database. And these are the tables. As I said, except for projects and technicians, the last two tables, the rest are from the sample database. I will explain these two tables shortly. And you can type in your query in this area in the middle, and you will see the results. And this is the button to run the query. I will explain the queries and the syntax later. So here I am simply trying to, with this SQL command, I am simply trying to look at what is in the projects table. So I say select star from projects, semicolon, and you don't have to have semicolon, but typically all SQL commands end with semicolon. You can either click this or use Control Enter. If you click this triangle facing to the right, the query will be executed. And this is the set of data that's in the projects table. So this is how basically you run a query. And when you run the query, this is the grid interface. You can view the results in different forms. This is, I hope you can look at where I am at. This is the grid way of displaying the query. You can also see a chart. So the chart is automatically constructed. And then this is the columns in the, let's go back to the grid and then use the columns. So you can see these are the columns that are displayed. There are 4 columns in the result set. And although this is a tiny table with only 11 rows, in reality, we're in big data environment. It's not uncommon for you to come across a table that's a few 100,000 rows at least. And if you want to save that data into your local machine, you can use this. You can export the result in any one of these forms and save it to any location within your computer. And later on, you can take that CSV file, for example, and construct a Tableau visualization or a Power BI visualization, or use any of the other tools that can read those data formats. And your queries may be very complicated at times, and you will be construct the queries in different phases, and you can save your query for future use. And this is the default right hand side area where you will see the default projects and what is the columns in there. And you can also have a quick help on various functions that you can use in your SQL query. SQL, of course, stands for Structured Query Language. And here are the tables. If you expand the tables, you again can have a quick look at the columns in the table. And that's about it, I guess, as far as the interface is concerned. Let's get our feet wet and try to type in some queries. So here I said select star from projects. Select will give you the rows in a table. A table is arranged in a set of rows and columns. The columns are simply called columns, and the rows are in a relational terminology called tuples, but it's not uncommon to just call them rows. So we have 11 rows and 4 columns in the table. But you don't have to, you understand the syntax? The word select. Star means I want every column in the table. And from, after from, you have to give a table name. In this case, I'm using projects. If you want to look at a different table, you can say products, for example. When you say products and execute, you have to re-execute the query. and you have 100 plus rows, because it's a huge table and you have 6 columns and the entire table is displayed on the screen. And if you want to export it to a CSV file like I've shown you before, you can do so. So this is a frequently used statement, and some people say about 80% of structured query language is learning the select statement. Here we are learning the select statement in the context of Impala SQL, and if you learn it in one environment, typically your skills are transferable except for minor variations. What I mean to say is the syntax we are learning in this lecture is going to be different, slightly different, but still you can try. Most of the queries will run as is in, say, for example, Oracle environment or Microsoft SQL environment or MySQL. Except for minor differences, your skills are transferable. That's the point I want to get across to you. So select star from products gave you every column in the table, but you can see these are the columns, right, in the table. You can start typing in the columns. See, as soon as I start typing in PR, you have the pop-up window that gives you all the columns in the table. That is because I have already said select and I have already said from products. So the interface knows that I am selecting columns from table products. So it automatically pops up all the columns. So it's always a good idea, if you know what table you are selecting from, just type in select and put from and the table name. And after that, you can simply, let's say I want product ID. You have to put your comma. Then you say PR, product description. And then you can say maybe product name, comma, product price. Let's say I want only those columns. Okay. So I hit execute now. Okay. And now it displays only the 4 columns that you have selected. Okay. So that is basically how you retrieve data from using Impala SQL. So what is Impala SQL? Impala SQL is a structured query language. All SQL, whether it's Impala or Oracle or something else, is used to retrieve data from tables, and databases contains tables, and that's the hierarchy. You have databases, tables contains rows and columns, and you can use SQL to retrieve the data. SQL is an abbreviation for structured query language. So all SQL are used for data retrieval purposes. That's a common language that most databases understand, and hence the popularity of SQL. There are other interfaces, like if you go here, you can go to editor and you can use Hive, and you can use a bunch of other things. But basically in a big data environment, in the cloud data interface, at least you have the Hive queries and Hive HIV, Hive queries and Impala queries. Both work almost the same, except for very, very minor differences. But for the most part, we will use the Impala interface. And both Hive and Impala are used to access big data that is stored in Hadoop architecture. So what is Hadoop architecture? Again, the goal of this lecture is not to make you data scientists. If you want to learn additional stuff and become a data scientist, that's fine. But our goal here is just to help you retrieve the data from large data sets. So the Hadoop is you can think of Hadoop as an operating system for large amounts of data. So when we type in the query, it goes to the Hadoop architecture where the data is stored. So there is a cluster. It's called Hadoop uses HDFS, Hadoop Distributed File System, which means all the data, say for example in the products table, can be stored in multiple machines. Okay, this is typically referred to as a cluster. So let's say there are a million rows in the products table. I haven't checked how many rows are there. It is quite possible that these million rows are stored in, let's say, 4 or 5 machines, which are part of the cluster. And then, however the data is split, is replicated across multiple machines. You understand this point? So a million rows could be in 3-4 machines, and the 3-4 machines again are, let's say 3 machines. Then you have the first 3 machines stores million rows, the second 3 machines stores exactly the same million rows in exactly the same fashion as the first 3. So what is the purpose? The purpose here is to build redundancy, meaning when you supply this, when you execute this query, it goes to a master node, and the master node looks at the query, determines the tasks involved in answering that query, and it subdivides the task into smaller tasks. You may not clearly understand what those tasks are, but think of whatever needs to be done to fetch the results of the query consists of 3 different parts, and each part, you can say is a task. And when this query is executed, it goes to a master node and it distributes the tasks or the parts of the query to multiple what are called worker nodes. The master nodes and worker nodes are still part of the distributed file system. And this same task is executed across multiple machines, and whichever machine gets done with its task, it supplies the result, and the results are streamed to the interface that you are currently seeing. That is basically what is Hadoop architecture and how the big data works. Okay, so that's all you need to know for now without getting into the nitty-gritty details of what is behind this underlying architecture. You just have to be familiar with the fact that the query is executed across multiple machines, and because you are retrieving large sets of data, the speed of the query is very, very, very important, the speed with which the query is executed. Now let me go ahead and rerun the query. Okay, so you can see here it took 0 seconds. You see this area here, we are in our default database, and the query took only 0 seconds. And if you run a bigger query, it may take, of course, very long time, and typically big data queries might take really, really long time. Let's run the same query in Hive. Okay. I don't have access to the same query. So this is the query. See, there the query history, and in case you forget, you can go back to the query history. Now I am copying this and go to the Hive interface and type in the same query, and let's see how long it takes. It still takes 0 seconds, but typically when you run this with larger data sets, The Hive query will take a longer time. You can observe as we go through this lecture and try different queries. So you have already seen how we do this. Another thing I want to point out is I'm not really telling you how to create the tables and what are the different data types and how you should be conscious of the data types when you run your query, when you create your tables and so forth, because I'm in this lecture at least focused mainly on retrieving the data, again I must mention, from a business analyst perspective. Before we move on and look at other SQL queries, one point I would like to really emphasize is that SQL queries you must approach with a respect. SQL is a relatively simple language to learn, but simply because you got a SQL query syntactically correct, it doesn't mean you are fetching the results that you really want. In this case, there is no complexity. You want 4 columns from a table, so you are obviously correct in typing the query. As you get into more complex queries, you might want to double check the logic of your query. Simply because the query is running correctly and fetching you the results, it doesn't mean that you are getting logically correct results. And especially in the big data environment, this is very, very important because many strategic and tactical decisions are based on the results of your query, which you are going to further analyze. If you get this step wrong, naturally your predictive modeling is going to be wrong, and everything else that you want to do with the data is going to be wrong. And that's a very unfortunate situation to get into. So please pay attention to the SQL query. And the second thing I would like to emphasize is because Impala SQL is focused on big data and fetching the results, it lacks some of the statements. We call them transaction-oriented statements that other SQL languages have, such as rollback, commit, and all that. And you may not, of course, understand what all this means right now, but just be aware the goal here is online analytical processing, OLAP, and the goal is not OLTP, online transaction processing. If you call your utility company and want to know how much money you owe, you want them to be accurate, you want them to be fast. Okay, those two are not the primary goals here. Some SQL queries may take hours to run, so it's never as fast as getting the outstanding balance for a customer by a utility company. So it may run slow. And again, if you are off by, let's say the sales quantity is off by 100 units, it's not a big deal because you are typically looking at a historical set of data, and 100 units is no big deal. You might be surprised that I say this. No, we have to be accurate at all occasions. But typically, if you reflect on where the data is coming from, the data is coming from multiple sources in a data warehouse where the data gets loaded into a single big data table, let's say. So these multiple tables may have slightly different meaning. One table might call a column sales and it's sales before returns, and the other table might call the same column sales but it's after returns instead of reconciling. Because of the inaccuracies involved is not that big a deal, you may sacrifice some accuracy in the case of big data. Okay. So these are the points I would like to emphasize in the first lecture. You already know how to retrieve your data, how to retrieve data of just a few columns, and that completes our first lecture.